Weather. It is the day-to-day changes in the atmosphere. From serene to extreme, weather is the motion of meteorological elements. Without the sun, no air would move on Earth. The sun is our nearest star. It is the source of energy for our planet. Averaging 93 million miles away from us, the sun sends light on an 8-minute journey, along with heat, energy, and other radiation through the vacuum of space. It is the engine for weather, causing water to change phase from ice to liquid to vapor. The sun heats Earth unevenly. Direct rays nearer the equator keep that part of the globe warm, while a low sun angle at the poles doesn't provide as much heat. In a given region of Earth, heat absorbed from the sun depends on the type of land or water surface, cloud cover, and snow cover. Heat from the sun makes air move as wind. The rotation of Earth on a tilted axis around the sun also gives different amounts and durations of heating throughout the year. This is the reason for seasons. In the summer, the sun is high in the sky, making the rays more direct and intense. Summer daylight hours increase. The winter sun is low and weaker, and the hours of daylight are fewer. In fact, at the North Pole, there is no sun in the winter, but there is 24 hours of sun in the summer. Seasons play a big role in what weather extremes we might face at any time of the year. Where sunlight is strong or plentiful, solar panels can harness the energy and convert it to electricity. Extensive arrays of solar panels provide power to communities. Rooftop solar water heaters directly use the heat from the sun to provide hot water to homes and businesses. Sunlight allows us to see our environment. It helps our bodies produce vitamin D for health. Sunlight directly allows photosynthesis in plants, which gives them life and in turn gives us oxygen. We benefit greatly from the sun's energy. However, that energy can have negative consequences. Ultraviolet radiation from the sun is what causes tanning. Too much exposure to intense sun leads to sunburn, which can damage skin. Over years, excessive sun exposure can lead to cancers of the skin like melanoma and diseases of the eyes called cataracts. Ultraviolet radiation reaches the ground on cloudy days too, so always account for how long you may be outside. Take precautions by limiting your exposure. Apply sunscreen with a high SPF, sun protection factor. Wear sunglasses with UV protection and light-colored clothing to cover your skin. The sun is white hot to our eyes. We can't and shouldn't look directly at it when it is high in the sky. However, light from the sun lets us appreciate color. It highlights the bright white of midday clouds. When the clouds are thick, the sun cannot penetrate them, so the clouds appear gray. As the sun lowers in the sky, we see other colors of the spectrum, like yellow, orange, and red. Sunlight passes through more atmosphere when the sun is close to the horizon, so colors with longer wavelengths are more dominant, while colors with shorter wavelengths are scattered out. This is why sunrises and sunsets often present dazzling and brilliant sky and cloud colors. Just about any color imaginable can be seen in the sky as sunlight interplays with air and moisture. The moon reflects light from the sun. It also takes on a tint when it rises and sets. The color of the moon or sun depends upon how clean the air is. The hue is shifted by dust, ash, soot, pollen, or other particles in the atmosphere known as aerosols. Even when the sun sets below the horizon, The afterglow tints the sky and clouds. Sunlight lets us admire the deep blue of a clear sky. Sunlight is refracted by water droplets or ice crystals and is separated into the 7 colors of the spectrum: red, orange, yellow, green, blue, indigo, and violet. The acronym for the color spectrum is Roy G. Biv. Earth's atmosphere is extremely thin compared to the size of the planet. If Earth were the size of a soccer ball, the atmosphere that we live in would be as thin as a single layer of plastic wrap. When you fly cross-country in a jet airplane 6 miles above the ground, most of the atmosphere that creates weather is beneath you. It rapidly thins with height. Weather occurs in the lowest layer of the atmosphere called the troposphere. It's where there is rising and sinking motion due to uneven heating from the sun and from varying topography. The air in the troposphere is mostly nitrogen and oxygen, with small amounts of argon, carbon dioxide, hydrogen, and other gases. Air also holds varying amounts of water vapor. That is vital to life and weather. In the troposphere, the temperature gets colder with height. The amount of water vapor decreases with height, and the air pressure decreases with height. There's less air as you climb in altitude, so it is less dense and cannot hold heat very well. That is why the tops of tall mountains, even near the equator, remain cold with snow on them. The one thing that does increase with height is the average wind. These winds above the ground are what steer weather systems around the Earth. Given the greater density of the gases and water vapor low in the troposphere, a large amount of the sun's heat is trapped near the ground. Without the troposphere, planet Earth would be a much colder place, unsuitable for life as we know it. Sometimes temperature does increase with height. This is known as an inversion because the temperature trend is inverted from typical. Temperature inversions result in stable weather because the warmer air aloft limits rising motion or convection. They are not unusual after clear, calm nights with no wind. When temperature inversions persist for days, they can cause bad episodes of stagnant air and pollution. The atmosphere as a whole captures and sends back out to space about 30% of the radiation arriving from the sun. For the other 70% of the radiation, most reaches the ground, where it is absorbed as heat, while a smaller portion is absorbed directly by air. That's not the end of the process. All incoming solar radiation, also known as insolation, is re-emitted at different wavelengths between air and ground and clouds and water. Ultimately, there is a balance between the amount of energy coming into the Earth's atmosphere and the amount leaving. This holds the planet at a nearly steady temperature. Most of this balance occurs in the troposphere. The 3 components of the balance of energy are radiation from the sun, conduction of heat absorbed at the ground to the air adjacent to the ground, and convection, or rising air currents in the atmosphere. Beyond the troposphere is a layer of the atmosphere where there is not much rising and sinking motion. The air movement is mostly horizontal and stratified. This layer is called the stratosphere. There's very little oxygen there, but there is ozone, which absorbs radiation to make the temperature increase with height. The layer of ozone in the stratosphere protects life below from high levels of ultraviolet radiation. Ozone is a form of oxygen composed of 3 oxygen molecules, but we cannot breathe it. The oxygen we breathe is composed of 2 oxygen molecules. The tallest thunderstorms can reach the stratosphere, but when they encounter the stable air and horizontal wind of the stratosphere, about 12 miles up, they spread out and form a shape like an anvil. Because of the lack of moisture and air in the stratosphere, very little weather occurs there. Two other layers exist beyond the stratosphere, the mesosphere and the thermosphere. These layers also protect us from high-energy radiation from the sun. The thermosphere is the edge of space. It is within the thermosphere where bursts of radiation interact with Earth's magnetic field to produce the aurora. High-energy particles travel from the sun and what's known as the solar wind. The particles constantly bombard our planet, and they are focused by the magnetic field around the North and South poles. These are not directly dangerous to people on the ground, but when the sun emits large quantities of them, they can disrupt GPS systems and interfere with electrical power grids. They may force pilots to divert flights from over the poles for safety from excessive radiation in the upper troposphere. Most noticeably, this rush of particles across Earth's magnetic field creates brilliant displays of the aurora. Seen from the International Space Station, you can compare the aurora to the relatively thin atmosphere surrounding the Earth. Much of the aurora happens about 50 miles above the ground. A display of an aurora is a geomagnetic storm, and in the Northern Hemisphere, it's called the aurora borealis, or the Northern Lights. The troposphere's air serves as a blanket that allows life to exist as we know it. Air is mostly nitrogen, N2, followed by oxygen, O2. Nitrogen accounts for about 78% of air, while oxygen accounts for about 21%. Hydrogen is only a fraction of a percent. There are much smaller quantities of other gases in air making up the remaining amount. The one gas that varies the most is water vapor, H2O. Water vapor can be as much as 4% of air. Everything directly or indirectly benefits from water and water vapor in the air. Plants benefit from nitrogen, and humans and animals benefit from oxygen. Air is a gas that flows, moves, changes shape, and expands and contracts. While energy from the sun moves the air, air in turn moves heat and moisture around the Earth. Air allows the planet to maintain a fairly consistent average temperature. Air contains natural and man-made particles and compounds known as aerosols, and these too travel within air. Some are irritants or pollutants, depending upon where they are found. They may move hundreds or thousands of miles across the planet. This NASA GEOS 5 animation shows global movement of aerosols. The red and yellow dots are natural or man-made fires. Carbon aerosols are green, yellow, and white. Dust is orange and red.